Hey everyone, Professor Baldwin here, and today we're going to talk about inverse functions. An inverse function or an inverse relation happens when you interchange the first and second coordinates of a point, or if you have an equation, you interchange the variables. Our first example, we're given the equation y equals 4x minus 5. To find the equation of the inverse relation, we're going to exchange the x and the y. So that equation would be x equals 4y minus 5. Now at the same time, we need to talk about one-to-one functions. A function is one-to-one if different inputs have different outputs, or if a doesn't equal b, then f of a doesn't equal f of b. Or if the outputs are the same, the inputs are the same. So if f of a equals f of b, then a equals b. We're going to use the second one to check if the given function in this example is one-to-one. So we're going to use f of a equals f of b. And remember what that means, function evaluated as a. So we substitute a in for our x's. So this on the left side is a cubed plus 1/2 equals, on the right side, we need to substitute in the b, which is b cubed plus 1/2. If we subtract 1/2 from both sides, we're left with a cubed equals b cubed. We can take the cube root of both sides. So take the cube root, and we're left with a equals b. Therefore, this is one-to-one because f of a equals f of b, what we started with, resulted in a equals b. Now let's look at an example of finding the formula for an inverse. So above, we found an equation for the inverse relation, and we just exchanged the variables. To take it one step further and actually find f inverse of x, you need to keep on simplifying until you get to y equals. So first we would need to determine if this is one-to-one. So we would use the process from above, and I'm going to tell you that yes, this is one-to-one, just because I want to concentrate on creating that formula for the inverse. Now notice that this function is the same as y equals x plus 4 over x minus 3. And our first step is to exchange that f of x with y. Now step 2, we need to interchange our x and y. So x equals y plus 4 over y minus 3. Now let's assume this is x over 1, so we can cross multiply to simplify. So we have x times y minus 3 equals y plus 4. Remember, we're trying to solve for y, so we need to distribute on the left. xy minus 3x equals y plus 4. We want to combine the y's, so let's subtract y from both sides. We have xy minus 3x equals 4. Let's add 3x to both sides because remember, we're trying to get y by itself. We have xy minus y equals 4 plus 3x. Let me carry this over to the other side, give us a little more space. Now notice on the left that these two terms have y in common, so we can factor out the y, and we have x minus 1 and 4 plus 3x. Now if we divide both sides by x minus 1, we're left with y on the left, and on the right we have 4 plus 3x over x minus 1. So we've completed step 3, solving for y. Now we just replace our y with f inverse of x is equal to 4 plus 3x over x minus 1. Okay, now let's look at what a graph of a one-to-one function looks like. So here we have a graph of a one-to-one function, And remember that the graph of f inverse is a reflection of the graph of f across this dotted line, which is the y equals x line. Since we know that the given function f is 1 to 1, we can sketch the inverse. And remember, to sketch the inverse, we can interchange the first and second coordinates. So let's start here on the bottom left. The first point is -5, -5. Well, if we interchange those, we stay at the same point of -5, -5. Our next point is 0, -3. If we interchange those, we're looking for the point -3, 0. And we're going to connect our dots. Okay, next point is 2, 1. Interchanging would be 1, 2, which would be here. And our last point, 5, 3, that would be the point 3, 5, which would be about here. So if you have a graph or you could quickly graph the function, it's easier to just interchange a few of those points and connect the dots in order to get the graph of the inverse function, like we just did. Now, remember composition of functions? Well, it's back. And we use it here to show us that if a function is 1 to 1. So if a function is 1 to 1, then f inverse is the unique function such that the composition in both directions is going to result in just x, the variable, our input. And for each x in the domain of f, and for each x in the domain of f of inverse, based on the composition you have. So in this example, we have a function f, and we're going to use the composition of functions to show that f inverse is what we're given. First, let's find f inverse of f of x. So remember, we're taking the f of x function and substituting it into the f inverse of x function wherever there's an x. So that would be 1 over 1 minus x over x plus 1. Well, we need to simplify. In order to simplify the denominator, we're going to rewrite 1 as x over x. And then we have 1 over, now we have a common denominator of x. We can do 1 minus x plus x. Notice that this simplifies in the denominator to just 1 over x. And 1 over x is just x. Okay, so it worked for the first. Now let's look at f of f inverse of x. So we need to take our f of x function, and wherever there is an x, we need to substitute in our inverse. So we should have this. That's a plus. Let's start simplifying the numerator. And that 1 we're going to rewrite as x plus 1 over x plus 1 minus 1 over x plus 1. And this is all over 1 over x plus 1. Concentrating on the numerator. So we'll leave the denominator alone. The numerator, we have a common denominator of x plus 1. So we can combine the numerators, which is x plus 1 minus 1. That'll simplify to x over x plus 1 over 1 over x plus 1. Remember, a fraction over a fraction, you can keep your first fraction and multiply by the reciprocal of the bottom fraction. Notice that the x plus 1s are going to simplify out, and this will also simplify down to just x. So it's true that the given f of x does have the given f inverse of x as its function. Okay, here's another little review of one-to-one functions and inverses and some key points. We'll go through some of these as we complete the last example where we have to graph this f of x function and we need to find the inverse of that function and also graph that. Let's start with graphing this given function. Remember, it's y equals 5x minus 3. This is a line, so we plot the y-intercept first. We can use our slope to get us a couple more points. Okay, so I have these points and I'm going to connect the dots. And I'm going to label this as my f of x. It might also be helpful to label these points. This is 2, 7, and this is the point 1, 2, and this is the point 0, negative 3. Remember, that's going to be helpful for when we have to graph the inverse. So how do we find the inverse? Well, we start by exchanging our variables. We have x equals 5y minus 3, and now we need to solve for y. So let's add 3 to both sides. We have x plus 3 equals 5y. Divide by 5. Each of those get divided by 5. And we have y equals 3/5, and this is actually 1/5 x. Or let's rewrite it. Y equals 1/5 x plus 3/5. Now, this one's not going to be as fun to graph based on that equation, but we can use those properties about a one-to-one function and how it reflects over the y equals x line. So if we take this first point, 0, negative 3, we're looking for the point negative 3, 0 for our inverse. And the point 1, 2, we're looking for the point 2, 1. Okay, let's connect those. And then the point 2, 7 would give us the point 7, 2, which would be right here. We would connect all of those dots and label this as f inverse of x. And there we've graphed both. The last thing to do is give the domain and the range for both. Well, if you look at them, they're lines, so the domain is going to be negative infinity through infinity for both of them, and the range will also be the same, negative infinity through infinity. A lot of little rules to remember for inverse functions. If you have a question or you come across a problem that you need help with, just leave it in the comments and I'll create a video for you.